Example 4, find the optimum strategies and value of the game. First thing I want to do is look for a saddle point. You look at the lowest number in each row, the highest number in each column. We can see there's no saddle point, okay? So that means this is not strictly determined. Players are going to have to mix it up. Now I look for dominated strategies. Row first. 1 is better than -2, but this 1 is better than -4. So no rows can get dominated. Now let's look for columns. -2 is better than 1, and -4 is better than 1. -2 is better than 0, but -2 is better than 1. 0 is better than 1. Nothing dominates, okay? So if there's no saddle point and we can't do dominated strategies, then we're stuck with this 2x3 matrix, okay? It's a weird one, and so that's where we're going to have to use Simplex Method. So what I would do is find the smallest number here, and it seems to be -4, so I'm going to add 4 to this matrix. Okay, let's see what we get. We would get 2, 5, 4, 5, 0, and 2. Okay. So we've got this new matrix. And that's representing our variables x1, x2, and x3. Okay. Now, what I have to do is set up the initial Simplex Tableau, and I'm going to skip a step here because you can see there are 2 different rows. Those 2 different rows are going to be need slack variables, because right now we're calling these inequalities once we set up the simplex problem, the optimization problem. So S1, S2, that's what we're going to have, S1, S2. So I'm just going to kind of cheat here and skip a step and say we need slack variables. We're going to need 1 for the top one in S1, and we're going to need 1 for the second one in S2. Then there's going to be a Z for the objective function. Okay, oops. And neither of these have a Z in it. Only the bottom row is going to have a Z in it. These are going to equal, once I put a slack variable in there, they're going to equal 1. And then as far as my objective function, you take your variables, and it's like if we were going to maximize Z equals x1 plus x2 plus x3, my 3 variables there. We would have to take all 3 of those and subtract them over to get them to the left side of the equal sign. And that means there's going to be -1s for each coefficient for the variables. Didn't need any slack because it's an equal sign. And there's a Z. But then once we moved everything over, this is going to equal 0. So there you go. There's the initial Simplex Tableau. That's a good start, but now we have to actually do the Simplex method. So here's the hard part. What you do is you look at these rows, and normally what you do is take the most negative one of these numbers. Since it's a tie, I don't know if it really makes a difference which one, but because normally I'm trying to make zeros, I like this column right here. I'm going to pick this -1 right here, this column, and what we're going to do is we're going to circle that column. Okay. Now, you look at the end, you look at this 1, and you find the ratio of that number to whatever you just circled. So 1/5 or 1/0. Okay, that one's undefined. So we're not going to be able to do that one. It's undefined. Normally what you do is you take the smallest positive of these ratios. And so that tells me that we're looking at row 1. And so we circle row 1. Now the number that you circled twice, this number 5 in this case, is called the pivot element. And you use that number to make the other numbers in the column 0. So this one's already 0, so that saves us a step. We need to make this -1 into a 0 using this 5. So here's where your rules come in. I'm going to say 5 row 3s plus row 1. That way I'd have 5 of these is -5 plus 5. That's going to give me 0. So let's just kind of copy everything, starting with the variables. We can copy this row. That was our pivot row, and it doesn't need to change. We can copy the second row because of this 0 right here. Because of that 0, it doesn't need to change. I just had to change that bottom row. Okay, I needed to change this into a 0 according to this rule. So do this rule all the way across. 5 of these is -5 plus this 2 in row 1. That gives me -3. 5 of these -5 plus 5 is 0. 5 of these -5 plus this is -1. 5 of these plus this is 1. 5 of these plus this is still 0. 5 of these plus this would give me 5. And 5 of these plus this would give me 1. Okay, so I've got a new Tableau, but I know I'm not finished because I have negatives on the bottom. So again, you go back with that same rule of look for the most negative indicator. That's the X1 column. And then you're going to divide number on the right by the number that you circled. You got 1/2 and 1/5. Don't worry about the bottom. So whichever of these two fractions is the smaller positive number, that's this one, that's what you go with. So I'm going to circle this row, paying attention to this number that I've circled in both the column and the row. That's my pivot element. That's what I have to use. So I'm going to use that 5 to 0 out the 2 and the -3. So here's my rule. I'm going to take 5 row 1, that would be 10, minus 2 row 2s. Okay. So let's look at what that would do. We would have, what, 5 of these is 10 minus 2 of these is 10 minus 10 is 0. And 5 of these is 25 minus 2 of these would still be 25. 25 minus 0. 5 of these is 20 minus 2 of these is 4. 20 minus 4 is 16. 5 of these is 5 minus 2 of these is 0. 5 minus 0 is 5. 5 of these is still 0, minus 2 of these, that's 0 minus 2 is -2. 0 minus 0 is 0. 5 of these is 5, minus 2 of these is 2, 5 minus 2 is 3. Okay. The circled row can stay the same. Now we need the bottom row. I'm going to get rid of this -3 using this 5. So remember, it has to do with the LCM. The LCM is 15. And so I can do 5 row 3s plus 3 row 2s. That ought to get it done. That would be -15 plus 15. Going to be 0 right there. So follow this rule. 5 row 3s plus 3 row 2s. That's going to be 0 plus 0 is 0. 5 of these is -5. Plus 3 of these is 6. Okay, -5 plus 6 is 1. Okay, great. Doesn't look like we're going to have any negatives. We'll see. 5 of these is 5, plus 3 of these, still going to be 5. 5 of these is 0, plus 3 of these is going to be 3. 5 of these is 25, plus 3 times 0 is, that's going to be 25. And 5 of these is 5, plus 3 of these, that's 5 plus 3 is 8. Look like that. Okay. Now, you know you're finished when you don't have any more negatives along that bottom row. Okay, I don't see negatives on the bottom row. I don't care about this negative. I'm talking about the bottom row. No negatives. I know I'm finished. So we should be able to read a solution here. Okay. X1. You look at this 5, make sure you look at this 1. That's going to be 1 over 5. That's 1/5. X2. This 25, make sure you look at the 3. That's going to be 3 over 25. X3, you've got too many numbers. You don't know which one to look at. That's going to be 0. Okay. Next, look at your slack variables. S1. Now here's something weird, okay? What we've done in the past is when there's extra numbers here, we always say that's 0. But this is different. I'm not really trying to find the slack variables. I'm trying to find this number right here, okay? So you look at this 5, and S1 is going to be 8 over 5. Okay, this is 8 over this 5, like that. And S2, same thing. I don't really care about these other numbers. I care about this 3. We're looking at 8 over 3. And then your Z number here is 8 over 25. Like so. Okay? So those would have been my solutions back in Simplex Method. Now we have to be able to convert those and read what the strategies are. Okay? So the row strategy, the row player you're going to flip the slack variables, okay? You're going to take the reciprocals, okay? So just take the reciprocals, and the row player is going to play row 1 5/8 of the time and row 2 3/8 of the time. Notice those fractions add up to 1. That's what tells me that we're on the right track. The column player is a little bit tricky because we have to do something weird with those X numbers, okay? So for the column player, we take those X numbers times the reciprocal of Z. So each of those X numbers we're going to multiply by 25 over 8. That's this Z number flipped. Okay. So in the first case, 5 goes into 25 5 times. We're left with 5/8. And in the second case, that completely cancels. We're left with 3/8. And in the third case, we get 0. So, of course, 0 times 0, or that's going to be 0. So our column player's strategy looks like this. Column 1, 5/8 of the time. Column 2, 3/8 of the time. And column 3, 0% of the time. Okay. Now for the value. For the value, we have to do something really weird. For the value, we have to take the reciprocal of Z and then subtract off the n number. Okay? Subtract off the n number. And that was this right here. This was n. Remember when we added that 4? We have to kind of cancel that out. Okay? We've got to get rid of that or undo that plus 4. And so we're going to subtract 4. 25/8 minus 4. So use a calculator if you want to, or get a common denominator. So times 8 over 8, got 25/8 minus 32/8. That's -7/8. That's the value of the game, -7/8. That implies that it's not fair because the column player would expect to win,